Hello and welcome to a new video on IGCSE Mathematics. In this video, we shall be discussing vector algebra. So in this question, we are given GH equals 6, -4. Find 5GH. So to find 5GH, we simply multiply 5 by the vector. And the 5 multiplies each number in the vector. So we get 30 and -20. Then to find HG in double I, you should know that HG is equal to -GH. So this is equal to -1 times 6 -4, which is equal to -6 and 4. And that would be the answer to double I. In B, we are required to find the value of y. So you should know that when we're adding two vectors, we add the first row, so 6 plus 2 equals 8. This is correct. And then also 7 plus y equals to 3. So therefore, y equals 3 minus 7. Y equals to 4, to -4, excuse me. So therefore, the answer would be -4. So I is 30, -20, double I is -6 and 4, and B is -4. In this question, we're required to write OA as a column vector. So OA is basically the same as A, but instead of writing as a point, we write it as a vector. So the x of A is 0, and the y of A is 5. So OA would simply be 0, 5. Now we want to write AB as a column vector. So you should know that AB vector is simply B minus A. And I'm going to write both of them as column vectors to make life easier. So B would be -3 and 4 minus 0 and 5. And we would get -3 and -1. So this would be the answer to AB. Of course, strictly speaking, this is actually OB, not B, and this is actually OA. But for ease of use, we just assume that A is the same as OA. Instead of writing it as a point, we write it as a column vector. This makes life easier for us while solving. So anyway, the correct answers are 0, 5, and -3, -1. Again, here we are required to find the column vector AB. So we should know that the column vector would be B minus A, and B is 5, 6, minus A, which is 3, 2, and this is equal to 2 and 4. In double I, we are required to find the magnitude of AB. So when we have these vertical lines like this is called the magnitude of a vector, and it's simply equal to the Pythagorean of the values in the vector. So we just apply the Pythagorean theorem here. We have 2 and 4. So vector AB from I is 2 and 4. So we simply write 2 squared plus 4 squared. And this would be root of 4 plus 16, which is equal to root of 20. So therefore, BI is 2, 4, and double I is root 20. Of course, here you can use your calculator to find the value of root 20 if you want to get it in decimals. And this is equal to 4.47 or 4.5. This would be correct. So 4.47 is the accurate answer. In this question, we are first required to find the magnitude of PQ. Again, we said that the magnitude is obtained using the Pythagorean theorem. So root of 5 squared plus negative 8 in brackets, all squared. So as not to confuse yourself, whenever you're applying the Pythagorean theorem, you can just ignore the negative. Because when you square, the negative is eliminated automatically. So you can just find root of 5 squared plus 8 squared, because sometimes people tend to write negative 8 squared in the calculator without proper brackets, and the calculator evaluates a wrong answer because of that. So when you're doing Pythagorean theorem, just ignore the negatives, and this will reduce the chance of mistakes. So root of 5 squared plus 8 squared, this gives us 9.433. So 9.43 would be the correct answer here. In double I, we are told Q is 2, -3, find P. So PQ equals Q minus P. We are given PQ as 5, -8. This is equal to Q, which is 2, -3, minus P, which is something we don't know, so let's call it A, B, or whatever. And then we want to find A and B. So we can write two equations here. 5 equals 2 minus A. -8 equals -3 minus B. And we want to find A and B. So simple algebra. We just take the A to the other side and the 5 to the other side. So A equals 2 minus 5, which is -3. And here as well, we're going to take the B to the left. I'm going to take the -8 to the right. So B equals -3 plus 8, which is equal to 5. So therefore, point P can be written as 3 and 5. But this is actually, we said that this is not very accurate. Scientifically, this vector is not called P, it's called OP. So it would be best when you're writing the point to write it as a normal point like this, -3 and 5. It's easy to go from vector to point. The top element becomes the X and the bottom element becomes the Y, and you just write it in the format of a point, and that would be correct. So 9.43 and -3, 5 are the correct answers in this case. MT equals 2K minus K, or 2K and -K. And the absolute value of MT, or the magnitude of MT, is root 180. Find the positive value of K. So what is the magnitude of K? So the magnitude of K would be the magnitude of MT, I apologize. The magnitude of MT is equal to the Pythagorean of the elements in this vector. We said we can just ignore the negative sign as if it does not exist. So we just have 2K squared plus K squared. So this would be root of 4K squared plus K squared. And then that would be root of 5K squared. Now, this is equal to root of 180. So since they are both in roots, we can just square both sides. And then we would get 5K squared equals 180. You can divide by 5. So K squared equals 180 over 5, which is equal to 36. So therefore, K is either +6 or -6, the square roots of 36. So they want the positive value. So therefore, K equals 6 is the correct final answer. We are given three vectors, OA, AB, and AC, and we are required to find the magnitude of OB. So, like we said, OA can just be A, and AB is B minus A. So we have an equation that we can write here. AB equals B minus A. We have the values of the vector AB. We do not have the values of vector B. So let's call them A and B, for example. And then minus, and the vector A or OA would be 4 and 3. Now we want to get B, so we can just take the vector to the other side as if you're taking the A to the other side. So here, this would be B equals AB plus A. And in the same sense here, B, or let me write it as a vector. So B is A and B. This is the value of B. So let me write that down. This is equal to AB, which is 8 and negative 7, plus A, which is 4 and 3. This is another nice way to evaluate vectors. We just took this to the other side and we changed the sign so it became plus instead of minus. And we simply evaluate it in one shot like this. We get 12 and negative 4. So this would be the value of B as a vector or OB vector. That's 12 and negative 4. And then to get the absolute value of the vector, the magnitude of the vector, all we have to do is do the Pythagorean theorem and ignore the negative as we said before. So 12 squared plus 4 squared. And that would be radical 144 plus 16. So radical 160. You can get it as a decimal using the calculator. Radical 160 would be 12.6. And that would be the final answer for question I. Now, for question double I, we want to get the vector BC. So how do we get the vector BC? Simply, there are two ways. First of all, you can think of BC as C minus B. And then to get BC, we need to first get C. But that will be very complicated. Another nicer way of thinking about this is to understand that in vectors, the initial point and the final point are what matters. So in another way of saying this, we can say, for example, that BC vector is the same as BA vector plus AC vector. How is that the case? Because it starts with B and it ends with C, and the middle terms are the same. So this equation is valid. And this would be much easier because we already have most of what we need. In fact, we have all of what we need. So to get BC, we can just do it in one simple step. So BC vector is, let's call it X and Y, for example. And this is equal to BA. So what is BA? Since we already have AB, we are given AB here. So since AB is equal to 8, negative 7, BA is simply the negative of AB. So that would be negative 8, positive 7. We just negate the signs of each term. So BA would be negative 8 and 7 plus AC, which is negative 3 and 6. And that would give us negative 11 and 13. And that would actually be the correct final answer. If this is confusing you, you can also solve it using this equation here. It will take some more work, but it might be easier to understand for you. So I'll just solve it this way as well. So we want to get BC, and we know that BC equals C minus B. But the problem is that we do not have C. So we need to figure out how to get C. So C can be obtained from AC because AC equals to C minus A. So we can say that C equals to AC plus A. And then we have AC and we have A. So AC would be negative 3, 6 plus vector A or vector OA, which is 4, 3. And then we can get vector C by simply adding these two vectors. So we get 1 and 9. Now we can use the vector that we obtained. So we have 1, 9 minus the vector B. We already got the vector B in the previous problem. We already have the vector B here. So we can just write 12 and negative 4. So 1 minus 12 would give us negative 11. And 9 minus negative 4 is 9 plus 4. So that would give us 13 as well. So this would also give us the same final answer for vector BC. You can use whichever way you like. Both of them would work. And the final answer for the previous question, like we said, is 12.6. Now let's check the marking scheme. So 12.6 is correct for AI, and negative 1113 is correct for AII. In this problem, we are given M and we are required to find 3M. So finding 3M is very straightforward. So you simply multiply 3 by the vector and you get 15 and 21. In II, you are given a vector and you are required to find the magnitude. This is simple as well. All you have to do is do the Pythagorean of both values, ignoring the negative sign. And that would give us root of 10 squared plus 24 squared on the calculator. That would give us 26 as a final answer. So 15 and 21 for the first one, that's correct. And 26 for the second one is correct as well. In AI, we are required to find 2p plus q. So let's write this down in terms of vectors. We have 2 multiplied by 4, 5, plus q, which is negative 2, 7. We distribute the 2 over both values in the vector. We get 8 and 10, plus negative 2 and 7, and that gives us 6 and 17 as a vector. So this would be the answer to I. For II, we simply find the Pythagorean of P, so that would be root of 4 squared plus 5 squared, and we can evaluate on the calculator. Root of 4 squared plus 5 squared is approximately 6.40. That would be the answer to II. So let's just circle our final answers. In B, we are told A is the point 4, 1, AB equals negative 3, 1. Find the coordinates of B. So in order to find the coordinates of B, we understand that AB equals B minus A. So therefore, B equals AB plus A. We just take the A to the other side. And then we write them down as vectors. So AB is negative 3 and 1, plus A, which is 4 and 1. We write it as a vector. And we get 1 and 2. Of course, we said that B is not really a vector, it's a point. So when they're asking for a point, it's better to rewrite the answer as a coordinate pair. So 1, 2 would be the correct final answer in this case. So 1, 2 is correct according to the marking scheme. 6.40 is correct as well. And 617 is also correct. D is the point 2, negative 5, and DE equals 7 and 1. Find the coordinates of point E. So like we said, we can write DE equals E minus D, final minus initial. And therefore, if we take the D to the other side, you can say that DE plus D equals 2E. And then we substitute this with vectors. So DE is 7, 1, plus D, which is 2, negative 5. And that gives us 9 and negative 4. And since, like we said, it's a point, we have to write it as a coordinate pair. So 9, negative 4. Now in B, we're told that vector V is t and 12, and the absolute value is 13. Work out the value of t where t is negative. So to get the magnitude of a vector, we apply the Pythagorean theorem. So root of t squared plus 12 squared equals 13. We can square both sides to get rid of the root or the radical. So we get t squared plus 12 squared, because of course the power 2 cancels the radical. So we're left with what's inside. And this is equal to 13 squared, which is 169. So t squared plus 144 equals 169. T squared equals 169 minus 144. And this is equal to 25. So either t is 5 or t is negative 5, because we take the square root of 25. And they want the negative value. So this is the correct answer. And we remove the positive value of t. So negative 5 is the correct answer for B. And 9 and negative 4 is the correct answer for A. The final problem in this video gives us 3 vectors. We are required first to find 3a minus 2b. So like we said, we just plug in the vectors into the equation. So 3 times negative 3 and 2 minus 2 times 5 and 4. This would be equal to the following. We first distribute the 3. So we get negative 9 and 6. And then minus. And then we distribute the 2. So we get 10 and 8. And then we evaluate the operation. So negative 9 minus 10, that gives us negative 19. 6 minus 8 gives us negative 2. So that would be the value of 3a minus 2b, negative 19 and negative 2. In double I, we are required to find the value of absolute a, or the magnitude of a. So we do the Pythagorean of the elements of a, but we ignore the negative, like we said before. So 3 squared plus 2 squared, and you use the calculator to evaluate. So 3 squared plus 2 squared under the root gives us 3.61. In triple I, we are told MA plus NB equals C. Write down 2 simultaneous equations and solve them to find the value of M and the value of N. So let's try this out. MA, so M multiplied by negative 3, 2, plus NB, so N multiplied by 5 and 4, gives us C, which is 14 and 9. We distribute the M and the N over the two values. So we get negative 3M, 2M as a vector, plus 5N, 4N equals 14 and 9. And then we form 2 simultaneous equations, one for each row. So we have negative 3M plus 5N equals 14. And we have 2M plus 4N equals 9. We want to solve these simultaneous equations. So we need to have a common coefficient. So let's, for example, multiply everything here by 2. And let's multiply everything here by 3 so that the coefficients of M become the same. Now we get negative 6M plus 10N equals 28. And we get 6M plus 12N equals 27. Now let's add the two equations together vertically. So negative 6M plus 6M, this gives us 0. And then 10N plus 12N, we get 22N equals 28 plus 27, and that gives us 55. So therefore, the value of N would be 55 over 22, and that would give us 2.5. And then we substitute it in either one of the equations to find the value of m. So let's, for example, take this one here. We have negative 3m plus 5n, so 5 times 2.5 equals 14. So negative 3m plus 12.5 equals 14. So negative 3m equals 14 minus 12.5. Of course, 14 minus 12.5 is 1.5. So m equals 1.5 over negative 3, which gives us negative half. So the value of m would be negative half. And these are the final answers for triple I. So negative 19 and negative 2 is correct for I. 3.61 is correct for double I. And for triple I, m is negative half and n is 2.5. This is also correct. This brings us to the end of our video. I hope this has been beneficial. Thank you for watching.